Hi, everybody. So in this example, we're going to take a look at this idea of looking for Nullclines and seeing what information about the long-term dynamics of a system of differential equations we can get just by looking at the Nullclines and not even paying attention to any other vectors in the vector field. So now we're looking at a system of equations where we've got R, which is our rabbits, and S is sheep. So this is different than the rabbits and the foxes, because as far as I know, sheep don't eat rabbits, and rabbits don't eat sheep, but they have a competitive relationship because they both have the same food source. So without even knowing what the equations are for this system, here we've got part of the vector field drawn in. And so the first part here is asking us to identify which of these lines is the R Nullclines and which of the lines are the S Nullclines. And so for the R Nullclines, keep in mind our R is like our Y here. So this would be like a Y Nullcline. And so we get an R Nullcline when we have dr dt equals 0, that's when we have an R Nullcline. And if the R dt is equal to 0, R again is our Y, then that means these vectors are going to point horizontally. And so I'm going to indicate these R Nullclines, these curves where all of the vectors along them are pointing horizontally. I'm just going to kind of sketch that in red. So that would be this one here, and that would be this one down here. So those would be our R Nullclines. And similarly, for the S Nullclines, S is now operating as our X. We would look for places in the vector field where ds dt seems to be 0. And if that is 0, that means there's no horizontal component to the vector. These are going to be vectors that are vertical, either up or down. And let me shade those in blue. So that would be this guy over here and this curve over here. So the ones in blue would be our S Nullclines. And an equilibrium point, let's remember that equilibrium points occur when both the S dt and the R dt are simultaneously equal to 0. So in other words, this is going to be an intersection of different Nullclines. And that's important to note here. So let me illustrate what I mean by that. So here's a point where a red line and a blue line intersect each other. So that's an equilibrium point. Here is a second equilibrium point. Red and blue are intersecting each other. Here's a third intersection point. And here's a fourth equilibrium point. And to be very careful, this point over here, where the blue line intersects the blue line, is not an equilibrium point, because this is just saying here's a point where the SDT is equal to 0. But it's not true that the RDT is equal to 0 at this point. So we need both of those derivatives to be equal to 0, so that means we need an intersection of different types of Nullclines. So where an S Nullcline intersects an R Nullcline. So we've got 4 equilibrium points that I've marked in black. So there's one here, one here, one here, and one here. And so if we're thinking about rabbits and sheep, okay, let's assume that both of these values are positive. So we're not going to live on the R-axis, and we're not going to live on the X-axis, but we're going to be in quadrant 1. And so these Nullclines have divided the region in quadrant 1 up into 4 different regions. So I'll number them. I've got a region here, 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 and here, and in the middle, we've got this equilibrium. And so what I can see, if I start in area 1, I can see that all of these vectors are pointing up, whether I'm here or over here, and they're all pointing to the right. So in region 1, our vectors should point up and to the right. So that means these vectors are going to point in that direction. In region 2, we can see this falls in between nullclines that are pointing either to the left or and up. So these are going to go up and to the left. So this goes in that direction. In region 3, we're looking at nullclines that are pointing down and nullclines that are pointing to the left. So in region 3, all of these vectors are going to point down and to the left. And in region 4, we're sitting between nullclines that point down and to the right. So over here, these vectors are going to go down and to the right. And so what we see is that no matter where we start with some positive sheep and some positive number for the rabbits, all of these solutions in quadrant 1, they all seem to be heading right into this equilibrium over here. So if I call this value S star, and this value over here R star, and here's the equilibrium, what we can see is that we're not getting this cyclic behavior that we saw in a predator-prey model, but in this competitive model where the rabbits and the sheep are competing for the same limited food supply, these populations over time are going to just head straight into the equilibrium that the rabbit population is going to approach R star, which we've marked, and the sheep population is going to be whatever that value is at the S coordinate is at that point. So here we can see it seems that we have a very stable equilibrium in the middle, which is a little bit different behavior than we got with the rabbit and the foxes, where we had cyclic behavior with the predator and prey models.